guys. So today I'd like to discuss the importance of data in statistics. Now, data is the most important tool that we get in statistics. Without data, wo- wo- it is the main ingredient that we perform our statistical analysis. Data is like the cooking ingredient that a chef uses in statistics. He may be a great chef, but if the data or the ingredient are bad, then the food will also be bad. Now, why do we collect data? Data is collected for three main reasons. The first is representation. So we collect data. There's an entire population and we are taking a survey of people. Okay. So what we do with data is we take a randomized sample population that kind of from the distributed data they kind of represent the entire data. So on that small data we can perform statistical analysis. So what it would help us do is that from a small sample data it will be easier to compute and find different things about the entire population. Now other another uses of collecting data is comparison. So suppose there are two kind of group. One group doesn't have any kind of health issues and the other do have some kind of health issues, and from that we collect both of their data and we find that those who don't have less issues, mostly the average population do more exercise than the one that don't do that do have health issues. So that is another thing. And the third point data is actually useful for just because it is we can collect data and it might be useful for any simple thing. If we know what actually is useful, we might not have to collect data in the first place. So data is collected in mainly two ways. One is longitudinal and the second is cross sectional. So cross sectional is taking two different kind of population and comparing them, while longitudinal is taking a single population and observing them for a long amount of time. Longitudinal data is better and but it is harder to have, and cross sectional data can have more biases into them. Now that data is useful, the more data we have, the better the statistical analysis we can perform. But there is one issue with data. The more bad data we have, the even worse the outcome would be, and the more confidence we would have on the bad data, and that is bad. So there are some points that usually contribute to bad analysis of bad data. The first is recall bias. Suppose that you take a population who has a specific kind of disease, and after learning that they have a disease, to cope up they came up that a specific kind of food ingredient made them more prone to that kind of disease, while those who didn't had a disease also used to eat that same food but they didn't used to cope. So when you will take the data and sample, those with actual disease will tell you from their memory that they consumed the same food, but instead what actually is happening here is those who actually had that in the memory they did it, and that leaked to it. So that's why longitudinal data is usually better. Now second is healthy bias. So generally we find that people who take multivitamin are usually more healthy. Is it because multivitamin is healthy, or is it because people who take multivitamin are more health conscious and that's why they are usually more healthy? So that is one kind of healthy bias. Next is survivorship bias. Let's say there is a ship and we found out that people who were preying on the ship mostly survived. But if we really find out that people who died also were praying, almost everyone was praying. It's just that those who were survived were also praying, and we concluded that praying is directly causes savior of people. So that is an example of survivorship bias. Another is selection bias. Suppose you want to calculate the entire GDP of a country, and you go to an airport and ask the people their average salary or income. So what would happen is you would get a good number and a high number. So you can conclude that the country has high GDP. But obviously here's the problem. People on airport would be obviously far more richer than the people who are in the in anywhere else. People who are taking airplanes are usually richer. So that the average of the population will obviously be high. Another is self selection bias. So let's say that you are taking a survey to find out that how friendly are people in an area. So what you do is ask 100 people that would they like to have survey or not. 40 of them do but participate in survey, 60 do not. And based on that 40 people, you you talk with them and you find out, you conclude that these papers are friendly. But if you really see from that 100 people, 60 actually didn't participated with survey. So what it tells us about it is that even though like 60 people were actually not friendly, they were serious people in some kind of hurry, but based on the selected data, people who actually were friendly and obviously likely to be participate more in survey, they self-select themselves, and that is self-selection bias. And final bias is the publication bias. Let's say that there are 100 studies done, and 99 of study finds out that something doesn't cause cancer, but obviously many other thing doesn't cause cancer. So they don't usually get published or get more famous. But there's one unusual study which luckily or due to some other reason produces a result which shows that something as of playing video game decreases the chance of cancer. So people will start to use them, but obviously logically there is not any direct correlation here. So that is another publication bias. Now with all this, what usually is used in statistics is the concept of randomization, where you take the most distributed population and randomly select people, although and most likely you come with a better population or representation of the entire population.